In our last video, we evaluated logarithms without using a calculator. We don't really know how to use a calculator just yet, unless you're watching this as a review video. However, it turns out there are two special logarithms that we can use on the calculator. The buttons are built in. Those two special logarithms are when we have a base of 10. In fact, we use log base 10 so often, we often just don't even write the 10. It's sort of the only time in math we see an invisible 10. We're used to seeing invisible 1s and invisible 0s, but we have an invisible 10. Since we use it so often, we call it the common log, and that button is the button you see if you press log on your calculator. That's why it didn't work before, because we can't change the base. This is the base of 10. And so in fact, let's just go down here and evaluate this. I want to use a calculator. These are going to be probably irrational answers, so I'm going to have to round these off. So I want to do log base 10 of 8, or just log of 8. We usually don't include the base. So when I press enter, I can see that that's where the 0.90 came from. And what I did down here was just I did a little bit of rearranging just so we could review that skill and just to check that this does actually work. So recall that when we rearrange these, the subscript number represents our base. Well, I wrote in the 10 because I didn't see it there. So 10 is the base. I want to raise that to this power. The answer to a logarithm is an exponent. So to test it, I can do 10 raised to the 0.9, and I see that, yeah, that comes out to be about 8. I rounded it off, or we rounded, that's why it's not exactly. Okay, so that's one of the buttons on the calculator. The other one that we use very frequently is when we have log base e. Remember, e is a number. It's an irrational number that goes on forever and ever and never repeats. It's about 2.72. We call e either Euler's number, named after the guy that kind of found it, or we can call it the natural base. That's where the name comes from, this next one, the ln, or natural log. It's out of order, like it's log natural, because it's from a Latin word, and you know from studying Spanish or French, the adjectives usually come after the noun. So it's ln, which stands for natural log. Anyway, all that is to say that that button is also on your calculator to use. So I can type in the natural log of 0.3. And again, it's probably going to be an irrational number, so that's why we rounded off to about negative 1.20. So that is the answer. If I want to check it to see that this works, the base this time is e. So actually, if you hit second ln, notice that ln and e are connected on the same button. They're reminding you what's going on. Same with log and 10 to the x, they're connected. So I want to do e raised to my answer, the negative 1.2. Just to test that this does work. You don't need to do this. And I can see that that comes out to be about 0.3. And let's take a look at an application problem real quick. I'm given an equation right here. It's about the wind speeds of a tornado after it's traveled a certain distance along the ground. And notice that this has a logarithm in it, and because there's no base, or I should say there doesn't appear to be a base, we know there's an invisible 10 right there. The good news is, yeah, I can use my calculator to evaluate this because I have a base of 10. So they asked me to find the wind speed when we have a tornado that's traveled 220 miles along the ground. So that's going to be our input value. So I should be able to just type this in my calculator and see what the wind speeds are. So I've got 93 times the log, and it's log base 10, so I can just use the log button. I'm going to plug in 220. Now, notice what my calculator did. It automatically opened up a parentheses when I typed in log. Now, you have to be very careful that since that plus 65 is not included in the logarithm, it's just being added at the end, make sure you close off your parentheses after the 220. Otherwise, you're going to get the wrong answer. So just be careful of that. That's the only way you could really screw this up, I think. So then add 65 to it, and there's where my answer came from, about 282 miles per hour.